So next curve nani exponential curve. Okay, so here it is. Till now what we solved a linear curve, and next second one non-linear curve. Of course these all things also coming under non-linear curves. So linear curve is nothing but only straight line, will say that, and non-linear curve is nothing but parabola, exponential curve and power curve. So these are the curves coming under non-linear curve, and our intention is to here to convert non-linear curve into linear curve. It means here it is whatever curves they are giving, exponential one and power curve, we are going to convert into linear curve. Okay, so for that, in that first one, let the exponential curve be y is equal to a e power bx. This is the first curve, so let me take it as 1. Let the exponential curve be y is equal a e power bx, and next taking log on both sides, taking, so here it is keeping in mind, in your calc you have two options, one is LOC button and another one is ln button. So for exponential one we use ln, and for rest of the one we use LOC button. Okay, keep in mind that one. So taking ln on both sides. Okay, so taking ln on both sides, and then what we'll get here, it is ln y is equal to ln a e power bx. Okay, ln a e power bx, and next ln y is equal, simply we can write this one. If you see that here we apply the formula, you know that log ab is equal, simply what we can write, log a plus log b. So this one we can write, already you people known that in your earlier classes. Log ab is equal log a plus log b. Here it is, if you observe this one, this is simply you can assume as a and this is b, and then simply what we can write, ln a plus ln e power bx. Okay, none. So simply we applied log ab is equal log a plus log b, and then ln y is equal, here it is what we can write, ln a as it is, no need to change this one, and again here we are applying the formula ln a power m is equal, simply what we can write, m ln a. Log a power m is equal m log a. So that one we are applying here. So that is nothing but simply what we can write, bx ln e. So bx ln e. So ln y is equal ln a plus bx. Since ln e is equal to always is equal to 1. Okay, why? Because that is coming under base e. So for that, ln e is equal to 1. So simply if you observe this one, is this in the form of linear curve or not? So which is of the form, simply we can write, which is of the form, which is of the form y is equal a plus bx. Capital Y is equal capital B capital X, and let it be taken as 2. Okay, so where y is equal, what about y? So where capital Y is equal ln y, just we can compare this one, in place of capital Y what we have, ln y, and next in place of capital A what we have, ln a. So capital A is equal ln a, and next in place of capital B what we have, small b. So that's why simply we can write capital B is equal small b, and capital X is equal small x. So just you can compare this one, capital Y is equal to ln y, capital A is equal to ln a, capital B is equal small b, and capital X is equal small x. Okay, so now equation 2 is what? Equation 2 is a straight line. So equation 2 is a straight line. So equation 2 is a straight line. So to fit a straight line, so someone keep. So to fit a straight line, so what are the normal equations? We have to write normal equations for these one. Okay, so this is a straight line. So simply how to write the normal equation? Summation y is equal na plus b summation x, and summation xy is equal a summation x plus b summation x square, b summation x square, and let it be taken as this equation 3. Okay, none. So like this you need to write, when you are writing, when you are solving the problems, you need to write this entire one. Okay, so entire part you need to write that one. So here it is, first what we chosen, let the exponential curve be. So y is equal to a e power bx. If they mention clearly in the problem. So if it is a straight line, if it is a parabola, they never mention that. But exponential curve means they will mention. Why? Because here it is, we'll discuss about two different types of curves. One is y is equal to a e power bx. Another one is y is equal to a b power x. Okay, so these are the two different curves we learned in exponential curve. So here it is, first curve is y is equal to a e power bx and taking log on both sides. Then ln y is equal to ln a e power bx. Ln y is equal, simply we are using the formula here ln ab. So ln ab is equal to ln a plus ln b. So that's why simply what we are writing, ln a plus ln e power bx. And next ln y is equal ln a plus, here it is, if you observe this one, this is the formula we are applying here. This is in the form of ln a power m, and simply we are writing as m ln a. And next we are not changing anything here, just we are writing as this ln y is equal to ln a plus, here it is having dx, and ln e is equal nothing but 1. And next we are comparing this one with the linear curve, so which is of the form capital Y is equal to a plus bx. So where capital Y is equal to ln y, capital A is equal to ln a, capital B is equal to small b, and capital X is equal to small x. Just we compare equation 2 with the above one. So this one we are comparing. Okay, so with this one we compared that. Then after that, equation 2 is in the form of a straight line, or in other words we can say that linear curve. So to fit a straight line, we require the normal equations. What are those normal equations? Summation y is equal na plus b summation x, and next summation xy is equal a summation x plus b summation x square. Okay, okay, none. So this one we are taking as equation 3. After that, we need to calculate all these values from the given data. So what they give the data, here it is having x values they will give and y values they will give. So this is the data they will give in the problem. If they mention capital X and capital Y also, just treat it as that is x, small x and small y. Okay, you can treat like that. Okay, none. So small x and small y. And next, come into this. After that, you can, so small x and small y, after getting the day, after giving data, so sorry, come on, x values, y values they'll give. By using the data, we need to calculate capital X and capital Y. And finally, our intention is fitting an exponential curve is nothing but what we are saying, finding the constants. What are the constants in the given one? A as well as B. So these two values we need to calculate. But here it is having, we know that capital A is equal to ln A, capital B is equal to small b. Okay, so if you find capital B, obviously we'll get small b also. Okay, so no need to calculate anything. But here it is, if you observe this, capital A is equal to what? So capital A is equal to ln A. So we require the value of small a. So small a is nothing but simply we have to calculate e power a. So finally, after getting these two values, small a and small b, we have to substitute in that. So therefore, y is equal to e power a. So e power a into capital B. So small a is nothing but this one, and e power bx. So b is nothing but what we are saying, capital X, and bx will write as this. So this is the way we need to calculate. Once if you perfect in this first curve, obviously you can get remaining one. Okay, so for every problem first you need to write the entire part. Okay, when you're solving the problems also, you should write the entire part. Okay, so keep in mind. So is it clear about it, this one? So first we are taking the curve y is equal to a e power bx, and we are proceeding that this is a non-linear curve and converted into linear curve, and that linear curve is nothing but a straight line, and a straight line, fitting a straight line we are using normal equations. So we wrote those normal equations here. After writing normal equations, we require the small values small a and small b. So already we know that capital B is equal to small b and small a is nothing but e power a. So after finding those values, so this value also you'll get from calc. Okay, so in your calc ln button is there. So press shift button and then ln. You will get e power. And next, capital A already calculated and capital B you already calculated. Just we need to substitute that capital A here and then we'll get the value of small a. And next, capital B is nothing but small b. So no need to calculate again. And finally, you have to substitute those values in the given curve. Once if you pop it in that, obviously you can get remaining this y equal to a b power x and y equal to ax power b. Both are same model. Okay, none. Now coming to the problem, we'll see that. Okay. So let us see the problem. First one. Determine the constants A and B by the method of least squares. If you want, you can write running notes also for this. Least squares such that y is equal to a e power bx. Y is equal a e power bx. Okay, and now coming to the data. So here it is x values and y values. So x values are here 2, 4, 6, 8, 10. So these are the values of x. And next y values coming to here 4.077, 11.084, and next one 30.128, and next 81.897 and 222.62. Okay, so this is the data they give. So here it is, determine the constant. So we need to calculate that. So determine the constants a and b such by the method of least square such that y is equal a e power bx. So here it is, they gave the curve. Okay, so specifically they mentioned y is equal a e power bx. Okay, first we need to write as this. Okay, what we mentioned? So first ways, so that one we need to write as this. So this one what we wrote here, you need to write the entire part. Okay, so when you're solving the problem, you need to write the entire part none. Okay, so entire part you need to write. Next, coming to the problem, here it is. So this is the problem we wrote. Now coming to solve this one, first you need to write as this what we wrote there, y is equal a e power bx. Y is equal a e power bx, and let it be taken as equation 1, and you need to write what we wrote there. So what we wrote, so first taking ln on both sides, the entire part you should write. Okay, so entire part you should write there. So then we have to calculate the values of a and b. So those values we have to write. Okay, none. So here it is. First, after writing this one, we write the normal equations, all those things. It means simply I am writing what we got there. So what we got it finally after applying ln y is equal ln a plus dx. This one we got it, and we compared that one. Capital Y is equal capital A plus capital dx, where capital Y is equal to what we said, ln y, and capital A is equal ln a, capital B is equal small b, and capital X is equal small x, right? So this one we wrote. Now, so we need to calculate the values of, and then we wrote normal equations here. Summation capital Y is equal NA plus B summation X. So B summation X, and next one summation XY is equal A summation X plus B summation X square. So these are the normal equations we wrote, right? So and let it be taken as is nothing but equation 2, and now equation 3. So by using this capital A and capital B, we'll get small a and small b. Okay. So first we need to calculate summation capital X, summation capital Y, and next summation XY and summation X square. Okay, none. So here it is coming to this, the values of x and y. So before that, the number of values, how many number of values are there? The number of values n is equal, so n is equal, how many values they give? 1, 2, 3, 4, 5. So for that, n is equal to simply what we can write? 5. The number of values n is equal 5. And next we need to calculate all those values. For that, simply what we can write? The values of x and y. The values of x and y, capital X and capital Y, are, why? Because all the letter what we have there, it is having capitals. So capital X is equal nothing but what? If you see here, capital X is equal to what? Small x. So for that, capital X is equal small x, and next to y values. So capital X is equal small x. It means what we have? 2, 4, 6, 8, 10. So why? Because small x has this capital X, and the small y what they give? 4.077, and next 11.084, and next 30.128, and 81.897, and next one 222.62. So this is small y. But what we require? Capital Y we require. So capital Y is equal to what? So capital Y is equal to ln y. So capital Y is equal to what here? ln y. So that values we need to calculate by using your calc. If you have calcs, you can take it and you can see that. So capital Y is equal to ln y. So press the ln button. So and ln of simply 4.077. So is equal, how much we got it? 1.405. Next, in the same way, ln of 11.084 is equal. So this is nothing but 2.405. And next one, ln of 30.128 is equal 3.405. And next, ln of 81.897 is equal simply 4.405. And last one, ln of, here it is 10, ln y, sorry. So ln y is nothing but 222.62 is equal, simply we'll get it as 17.025. So like this, you need to calculate all these values from your calc. We require only this one and this one. Why? Because here it is normal equations are completely in capitals. So capital X is equal nothing but small x. So this one, and capital Y is nothing but ln y. So this one. And now we need to add this one, summation capital X, and by adding this one we'll get summation capital Y. Okay, summation capital Y will get it. And next we require x square as well as xy. So capital X square. So capital X square is nothing but same as is this one or not? 2 square, 4, and 4 square is nothing but 16, 6 square 36, and this is 64, and this is 100. So by adding all these things we get the value as capital summation x square. And next xy we require. How will get the values of xy? So x is nothing but 2 into 1.405. And in the same way, 4 into 2.405, and next 6 into 3.405, and next one 8 into 4.405, and next one 10 into 17.025. So this is equal. So we need to calculate these values. So these values we need to calculate. So this is equal. So we need to get the values are here 2.810, and next one 9.620, and next one 20.430, and next one 35.240, and 54.050, 54.050. By adding all these values we'll get summation xy. So here it is, if we add those things you will get it as summation x is equal to 30, and next summation y is equal 17.025. So not here, this is actually you'll get it as 5.405. 5.405. By adding all these values we get 17.025. And next summation x square we get it as 220, and summation xy we'll get it as 122.150. 122.150. So these are the values. Now we need to substitute all those values in normal equations. So substituting equation 2 and 3. So equation 2 and 3 we need to substitute. You can see that summation y is equal to how much? 17.025 is equal, n is nothing but 5. So 5a. Summation x is nothing but 30b. And next one. So here it is 122.150 is equal 30a plus, and summation x square here 220. So 220b, and let it be taken as this is nothing but 4, and this is nothing but 5. Okay, solving 4 and 5. So like as straight line how we solve, same like that you need to solve. So I'm solving 4 and 5. So by solving the values of 4 and 5, we get the values of capital A and capital B. So here it is, by solving that you people will get A is equal 0.405 and B is equal 0.5. B is equal 0.5. But what we require? Small a and small b. So since capital A is equal to what? ln A, right? So that is nothing but small a is equal e power a. So e power a value is nothing but 0.405. So this is equal. So in your calci, press shift button and then ln button. Then you get e power. In that power you can substitute 0.405. Then you get the value is 1.499. And next small b we require. So but small b is equal nothing but what we got it here. So small b is equal capital B. So simply what we can write, small b is equal capital B. So it is equal to how much we got it? 0.5. So therefore y is equal to a is nothing but, here it is 1.499 into e power b is nothing but 0.5 into x. Okay, so like this is the required exponential curve of best fit. Okay, so this is the way you need to calculate that one. Okay, so here it is.